Hello, my name is Colin Doyle. I am a senior consulting engineer at Juniper Networks, at least for another 9 hours. I believe my new title changes in the system at midnight. Welcome to video 7 of my updated Apstra and EVE-NG lab series. This is an exciting one today. We're going to be doing DCI. It's a mix of configurations in Apstra, configurations on VMX routers. It's really fun. We get BGP policies. DCI is a good time. Let's start this video where we start all of them, a level set on where we are in our current state. Coming out of our last video where we set up our testing hosts and did a bit of testing, we now have 2 complete working yet not connected fabrics, DCA on the left, DCB on the right. We have deployed our VSRX bridges in a packet mode to spare us the pain and suffering of doing LAC-P bonded interfaces in Linux. We have configured the UMate client testing hosts that I'm using. We have tested connectivity within each respective data center between these hosts. And today we are going to interconnect these 2 fabrics so that we can test between the hosts in each. At its heart, over-the-top DCI has 2 steps: setting up the underlay, setting up the overlay. The underlay establishes loopback reachability between the border leafs in each data center. This is done by exporting using BGP the loopbacks of these borders up to our external firewalls. Up to our external routers. And sorry, I've done this before with VMX, but these are I've done this, late in the day. I've done so many of these videos. I've done this before with VSRX. I'm doing it with VMX today. Here, we advertise our loopbacks. Those are learned over here. We get our loopback reachability. That's the underlay. And then the overlay is peering directly between those loopbacks. We're not going to create a mesh. We're just going to take DCA border 1 and pair it with DCB border 1 and DCA border 2 to DCB border 2. Let's get cracking on that underlay. Starting here from all green, this should always be your starting point. We're going to do all of the config for the underlay in DCA, and then we're going to do the router configs for the upstream devices, the VMXs, and then we're going to do all the config in DCB. We want to start in staged physical topology, and we're going to click this border rack. Boop. Let me scroll my instructions here a bit. This is another situation where the workflow is a little bit different than the previous versions of Apstra. It used to be, just to back us up a bit, that you could click, I think it was right here, but there was a plus button or something. Maybe it was under nodes, but you could add that generic external system using an add, like a click and add button. The workflow, the way it works now, and this isn't like before when I was building templates and we kept the old workflow and we introduced a new workflow. The way to do this now is to click on the device that you want to add it to. And this would be the same if you were adding a new, let's say, external generic system here. You click the device, the leaf that you're going to connect it to, and then you click this button. And you'll see right here is where we need to add that generic system. So I'll go ahead and click that. It's going to bring up a new workflow. And we'll work through this. We have 2 external routers. We have EXT-RTR1 connected to DCA. We do need to specify that this is external. We're going to say nope to a representation of this device, and we're going to click next, and we're going to assign interfaces here. We know from our topology that these are connecting to GE3, no matter which DC we're in and no matter which border leaf we're on. We'll start by clicking this 3 for leaf 1, click that so that you can click the add link button. You'll note that it's grayed out until, so it's still grayed out, you click this and then you add the link. And in that way we have told the border leaves 1 and 2 that GE3 is connecting to that external router. Done and done, created. Now we see this external router here. I'm going to go ahead and click on it once, right here. And there is one bit of configuration that we need to add. That is under properties, we need to add an ASN. Come down here, click the edit button, and add in the ASN that we have. Sits outside the fabric, but I know what we're using because I have put it here. It's going to be 6501 there, 6502 on EXT RTR2. I'll save that. Now we need to create a routing policy. So click on policies here. Yeah, that's the right place. And then routing policies. And then click this routing policy button. The routing policy is called EXT router-policy. We are going to be importing extras only. And you can see over here in my notes, I say BCP 38. BCP stands for best common practice. 38 is just the number. BCP 38 essentially boils down to being a good steward of public IP advertisements, but it can also apply here. The rule is thou shalt not advertise a prefix that thou does not own, and thou shalt not accept a prefix that thou does own. This is to prevent route poisoning. I want to make sure that I only export the loopbacks that are in DCA from DCA, and I want to make sure that I only import the loopbacks from DCB that are from DCB. In fact, it's not quite that specific. I just want to make sure I'm not importing my own routes from DCB. So I'm going to create some extra import routes here. In fact, I'm going to create two. The first one's going to state 192.168.1.0/24. This is the loopback range for DCA. I'm going to give it a greater than or equal to mask of 32, and I'm going to deny that. And essentially I'm saying that if I see my own loopback prefixes in a route advertisement that's coming in from an external source, that I'm going to deny that route, and I'm not going to put it into I'm not going to take it from my rib in and import it into my rib. And then I'll just accept everything else. And I could be more prescriptive here if I wanted to be. This is just easy enough. Make this as fine-tuned as you like. You could literally put in that you're just going to accept the loopback prefixes from DCB, which is this 192.168.2.0. I'm just doing everything. And then we're going to change this so that we're only exporting our own loopbacks. Pretty straightforward, right? And then expect default. I'm leaving these checked because I always have. We're going to do a different kind of default later, and there's no defaults that are actually kicking around here. So it's kind of trivial. But if you happen to see that, you could uncheck those. When we do the WAN connectivity and the internet connectivity stuff, that's when we'll be injecting default routes into this. Okay, now we need to create a connectivity template. As we know from our previous videos, we need to take these connections, actually assign them to specific interfaces. These were automatically generated when we built our virtual networks. Right now, we're going to build a new connectivity template. And there's some terms in here that might seem a bit esoteric, but I will walk you through what they mean. Remember, since this is a GUI, we need to have some sort of visual representation of how we build a stack of interface and protocols for connectivity. And I think, honestly, I didn't quite click with me the first time I did this, but it's been a while, and now it makes a lot of sense. You have to figure out some way to represent this workflow, and I kind of love it now. You have these things they call primitives. I say we, Juniper, we call these primitives. And we're going to layer these primitives to create the link that we want to represent. In this case, it's going to be an IP link, right? We're doing IP, we have an IP address, a transit network that's assigned to an interface that we're then going to use for peering. So we start by defining an IP link. We're also going to be peering with a generic system. So we're going to go ahead and click generic system. This BGP peering generic system. And then we need to apply a route policy that we've already created. So this is what our stack looks like. And if you consider the configuration that you would need to do in a Junos CLI, this makes a lot of sense. I go in, I configure the interface, I give it an IP address, I go into protocols, I go to BGP, I define a peering group, I add neighbors, ASNs. Is it interface peering? Is it loopback peering? That really has to do with the IP address that I'm assigning. And then I have to have some sort of policy that defines how I'm going to import and export routes. I kind of love it. So in this case, there's not a lot of config we have to do, and we are going to come back in and touch this when we build the iterate on this for the WAN connectivity and connectivity to the internet. For now, this is all pretty straightforward. Traffic's going to remain untagged. We assign the default routing zone. This is the underlay. When we do the overlay, that's when we would have to assign a tenant routing zone. Now, that's not part of this. We're not actually creating peering during a DCI connection that is going to use that routing zone, because this is really just about creating reachability. When we create a connection that goes into the WAN or towards the internet, that's when we're going to have to create a connectivity template that specifically references the tenant 1 routing zone, because what we're doing is we're saying this tenant now has access to resources that are on the other side of this peer that are outside the fabric. So that's it. It's just default routing zone, untagged. We scroll down, BGP peering. The only bit of information we need to define here is that we are peering from interfaces, not loopbacks. And then we can apply the routing policy that we just created, external routing policy. Everything is now gray instead of red, and we can click create, and that is done. Let me just catch up with my documentation here. So now that this has been created, we can assign it to end interface, actually 2 interfaces, because we have a connection from border leaf 1 and border leaf. What? Hey! Oh man. All right, that should still be in staged. I don't know why it did that. Been having odd problems with Zscaler. Maybe I'll turn that off for just a moment here. Turn that off. Yeah, I'm recording stuff. Thank you very much. Stop messing with my lab access. And then, and tongue out. Okay. Now, once that's off and it stops proxying stuff, I'm just going to click refresh once here. And I'll do the same for Eve. You'll note that even though I got dumped out, see, I still have uncommitted config, so it probably just, yeah, see, I didn't click assign here, but I haven't lost any of the work that I was doing, which is really nice. We're connecting up to the external router from GE003 on both of these border leaves, so we assign this to both the border leaves. It's an abstraction. We don't need unique configuration for the border leaves. It's pulling this information out of a pool, so we just need to kind of direct it. We're defining relationships, an intent. My intent is to connect you to this upstream device. I don't need to get very specific. You have the resources you need to build these connections. All right, now you see we've got a little bit of red over here. We're probably gonna have to deal with that. So let's go click staged, and then that'll reset the view that we have, and we're on physical, and we see now that we are linking to an external generic system, we have to use that external IP pool that we created way back at the beginning. External links and save. All right. Because this is pooling out of a pool, and because we are connecting to an external system, we don't have the benefit of Apstra being able to configure our VMXs, nor do we want that. So we need to go look at what resources have been used. Now, if you do this in the same order that I'm doing it, it just starts at the lowest value and starts moving up. And that's how I can be fairly confident that the IP addresses that I have defined here are going to match. And in this case, just look at DCI and ignore the fact that I've got sub-interfaces. This is a final resting state topology. Right now, this WAN doesn't exist. There are untagged interfaces. Obviously, we're going to have to move to tagged when we deploy, but we're really just interested in this information, which once it's set will not change. The way that we view the information that was assigned is we'll go to staged, and then we'll click on virtual, and we'll go to protocol sessions. And here's where we will see the IPs that have been assigned and the ASNs. And I've done this so many times, I'm fairly confident that these ASNs still match, and they do, and that the IP transit nets, these /31s, match as well, and they totally do. Great. In my documentation, I do point out that you want to make sure that that matches. Note those. If you do this in a different order than I'm doing it, you're going to get different IP addresses, and that's okay. Of all the things that might be dynamic in this, and I've had that happen once or twice where I might have done something out of sequence, just come into your topology and don't try tearing everything down and then rebuilding it. Just come into your topology and just update the IP information. It's fine. It doesn't need to exactly match. It's not going to mess with anything. That's A-okay, and it won't create problems for you later. This isn't one of those things where, oh, you got the name wrong and now I'm going to reference it over and over and it's not going to make any sense unless you're constantly thinking about it. Nah, it's fine. If you get different IPs, just use different IPs. All right, so we're going to go ahead and commit this to data center A. And it's probably going to complain because now it's going to expect peering sessions with the external routers. Don't exist because we haven't configured them yet. But we are going to configure DCB before we go and touch the routers. So the workflow here is the same. It's somewhat reciprocal. Let's see here. So we first need to click on our border rack, click here, create an external system. This is DCB, so now the name is going to be different. Make sure you switch this to external, or else this none option that we're going to use isn't available. See, grayed out. So external, this is EXT-RTR2, just for sanity's sake. We're not going to name it the same thing, even though we could, because this is a separate blueprint. Make our life easier if we don't. Oh, yep, sorry. I got to switch it to no. There we are. Next. Same interfaces as the other data center A. So we'll just do this and click these and add those links and create. We need to click on EXT-RTR2 and configure that upstream ASN. In this case, it is 65002. This will match what we have defined here in our topology. Great. Now we got to create our routing policy. And this routing policy, ext-router policy. We're doing extra only, and then we're defining them specifically. Of course, now we're in DCB, so the routes that we are not going to allow are the routes that we originate. So this is B20, and oh, I better /24 greater than or equal 32. We deny that, and then we'll accept everything else. 0.0.0.0/032 permit, and we only care about loopbacks. Great, that's all. Create. We'll go to our connectivity template, add a template, ext-router-ct, layer our primitives. We have an IP link. We're using BGP peering to a generic system, and we're going to apply the route policy that we just created. Click the gear, tell it to use the default routing zone because this is the underlay. It is untagged for now. Scroll down, it is interface peering, and we are going to apply the external route policy that we just created. So we'll click create, looking good so far. Now we have to assign this to those interfaces. Done and done. Of course, we need to tell it to use the external link pool. We'll do that here. Good. And if I go to virtual and protocol sessions, and why are you still complaining? What's going on here? ASN generics. That's, what have I missed? That should be, hang on here. You, external router. Did I not click save on you? Oh, I guess I didn't. In this case, it is 65002. This will match what we have. All right, 65. Could have sworn. Maybe I just missed it. There it goes. I mean, it told me exactly what was broken. There it is. Okay, so it was probably just a browser caching thing. We got all green here. Again, you can go to virtual, check your protocol sessions. I'm just going to verify real quick. 4, 5, 6, 7. 4, 5, 6, and 7. Perfect. Great, great, great. And we'll commit. Oh, I'm leaving out a step. Hang on, before I commit that. Oh, and it's in the documentation that I have. It's just, well, oh wait, no, I'm sorry. It's part of the overlay stuff. Never mind. I'll get to the ESI-LAG MSB stuff in a minute, but that's overlay. So we're going to finish building the underlay first, and the MSB stuff doesn't matter because we're not building our ESI-LAGs yet. In the documentation, as you may have come to expect, I do have the set commands that are required for the VMX routers to peer properly. I will type out both of them. Why not? Because there's only two. So let's get into those right now. And you can download this documentation because I'm not going to leave it on the screen, or you can just type out what I'm doing. Go to the link to the Juniper Elevate community and find, I'll link to the thread that is associated with this video. That's where you're going to find the companion documentation. And that's where you can get that information. Configure. So we're going to do set system root authentication, plain text password, Juniper with a capital J, as always. Set system. I forgot to put a dash in the host name again. Hold on. I've got to go fix this everywhere. Enjoy.
Relative to body size, Pallas's cats have one of the shortest legs of any cat.
All right. Host names. Okay. So what was the last one? Set system host name. EXT. Oh, hang on. Switch that. All right, good. Dash RTR1. Boop. Delete chassis. And set interfaces LO0.0 family inet. Address 172.31.0.0/32. We're not, that's kind of future proofing for something else. We're not going to use that in the configurations we're going to do here. Interfaces GES000, I should say the configurations for our DCI inet address. This is the connection between the routers. This can be whatever transit net you want. EXT RTR1 and EXT RTR2, and here come the configurations for the DCI links to the border leaves. I am so sorry that you have to see that DHCP scroll. That will go away when I commit. All the good that does us now, just ignore it. 01/31 and set interfaces GE-002.0 family inet address 10.3.0.3/31. Great. Set system routing. Oh, wait, not system. Oops, set routing options. Autonomous system 65001. Set protocols BGP group DCI neighbor 10.100.100.1 peer AS 6502. That is, oh man, I hate that. 65002. Set protocols BGP group eBGP neighbor 10.3.0.0 peer AS 65102. That's DC border leaf 1. And set protocols BGP group eBGP neighbor 10.3.0.2 peer AS 65103, and that's border leaf 2. Great. Commit and quit. Boop. And RTR2. Very similar, but not the same. CLI configure. Set system root authentication, plain text password, Juniper. Oh, of course, enter Juniper. Set system host name with a dash, EXT-RTR. Not TRT, 2. It's close to the end of the day. Delete chassis. Set interfaces, LO0.0 family inet address 172.31.0.1/32. Set interfaces G000.0 family inet address 10.100.100.1/31. The other side of that link between the two external routers, set interfaces GE001.0 family INET address 10.3.0.5/31, set interfaces GE0020 family INET address 10.307/31. Right? Get that right? Okay, good. Set routing options, autonomous systems 65002. Set protocols, BGP, group, DCI, neighbor, 10.100.100.0, peer, AS 65001. Enter. Set protocols, BGP, group, eBGP, neighbor 10.3.0.4, peer AS 65202, and set protocols BGP group eBGP neighbor 10.3.0.6, peer AS 65203. Commit and quit. Terrific. Okie dokie. Close. Do some testing. Actually, I guess I could have left router 1 up. Sure, got that open, and let me open up router 2 as well. Bring these over here, and we'll, oh wait, what? Sorry, right clicked, and it's in the other screen for some reason when I right click. Great, I'm going to send to new tab group. I'll put these side by side, and I can set this to all active sessions and then send immediately, so I can look at these at the same time. Show BGP summary. We should be established right now. We've got our peers that are going to, I know, kind of carriage returns here. We should have 3 peering sessions. These are the ones that are going between the 2 external routers, and these 4 are the peering sessions that go down into DCA and DCB. So that looks great. We can also do a show route advertising protocol BGP, and we can look at what is being advertised between these routers. This one will type in .1, and then this one will type in .0. And we see that we are advertising the loopbacks from DCB from router 2, and we're advertising loopbacks from DCA from router 1. That tells us all we need to know about whether or not the peering down towards the fabric's working, which is why we focused in on the DCI link instead of checking all 4 of these. Looking good. Alrighty, let's move on to the overlay. This is actually much fewer steps because we don't have a router configuration to do. Like I said, we're now going to peer between the loopbacks on these devices. We'll start in DCB. We're already there. And I'm going to show you this. We have all this in the topology written down, but if you need to check the ASN and the loopback IP addresses, what you'll do is you'll come to staged physical and you'll go to nodes. And here in nodes, you go to border rack and you'll see the ASNs and you'll see the loopbacks. Ooh, rectangle, please. There we are. 2 and 3, these will match the loopback interfaces, which actually I guess I didn't put here on the diagram, but they are listed in my documentation as such. So we're good here. As I said before, if you follow the same workflow in the same steps in the same order that I'm doing them, this should all match up. But if you do need to go look, that's where you go look. So we're not doing B first. We just collect that information to B. Then we go to DCA, staged. We go to this DCI tab. This is new. There used to be an external routing, or external routers. There was another tab here, like right where fabric settings is. Now we click on DCI, which is great because we are going to use integrated connect later. Right now we're using over-the-top gateways. So we'll create an over-the-top gateway. We'll give it a name. We've got 2 gateways to define because we're peering between the border leafs. We're not meshing them, so there's just 2. 192.168.2.2. That's the loopback of the remote gateway. That's why we have to do the underlay first for obvious reasons. Hopefully I don't have to explain that. And the local gateway that's going to connect to is this border rack leaf 1. So we've got B border. Actually, let's type that all out correctly. Boy, sorry, this is evening brain. I'm so close to being done with my day. And this is, I think, 4th or 5th video I've recorded. You'll know because you'll watch through the series and I'll be wearing the same shirt. So that's how you'll know. All right, that's done. We can click create another and we'll make B dash border 2, 192.168.2.3 and 65.203. Right. Scroll down, we'll connect that to border 2 and we'll say create. Now, this is important. This is used for stretch L2. If you have different subnets in each of your data centers, you can do type 5 only. It's a good optimization. We're not going to get into stitching in this series. It is supported. I'm just not showing it to you. Again, just time constraints. It's got to be an end somewhere, but that's fairly well documented as well. So if you get to that point, you need help, we can help you. That's done. I'll go ahead and commit this and we'll go do this reciprocal configuration in DCB. All right. Blueprints, DCB, staged, DCI, OTT, external, A, border 1, 192.168.1.2, 65.102, that would be assigned to leaf 1. Create. Oh, I didn't click create another's. Turns out it won't jam me up too much. Now we have A dash border 2, 192.168.1.3, 65.103. Scroll down, all routes. Usually that's checked. That was odd. And there. Great. Done. And uncommitted. Commit. Done. All right. That finishes DCI. Now we do need to let everything bake in and let the peering sessions come up. So I'm going to once again pause. And when we come back, we'll test between our hosts and see if we are in the place we need to be. If not, like I always do, I will show you what's wrong and I'll show you how we fix it. Be right back. All right, here's where we're at right now. Everything's green. I actually should have just not paused because it took no time to get to this point. I did remember that there's something I need to do. I kind of glazed over it in the doc. It is in the documentation, but I forgot to do it. It is this slide 31, and we need to go change the ESI-MAC most significant bit. And while we're navigating there, I'll explain why. When you deploy a fabric in Apstra, it's got code that it uses to generate values, right? You can do pools and then give it resources, but you'll note that as I'm going through and I'm building all these links that are drawing information out of those pools, that I don't need to go check everything because I've done this enough time to know that it's pretty predictable how this stuff's generated, and it should be. That makes a lot of sense to me. We don't try to intentionally randomize how it is creating information, which brings us to the most significant bit in ESI-LAG configuration. I'm in DCB right now. I'm going to leave DCA alone because the rule is this just can't match when I have stretch L2 between two data centers. When the ESI values are calculated, this is Ethernet segment identifier, and they need to be unique for every LACP pair that we have. When these are generated, they are generated in a way that means that if I have two fabrics and this value is the same, I'll have identical ESI values in my lags between the fabrics. And that breaks all sorts of stuff. An ESI value, if you're not familiar with ESI-LAG, Ethernet segment identifiers are all zeros when you're not doing lag. And when you are doing lag, the fabric needs something that it can code into, I'm going to say they are type 2 route advertisements that allows the fabric to understand, the control plane to understand what interfaces on what switches are participating in that lag. That means that if I don't change this value, I am going to essentially have a fabric that thinks that this lag and this lag are the same. And you can understand that is gross. What would happen is I would get on this leaf, and this wouldn't be reachable from anything over here. And I'd get on this leaf and I'd try to see what the next hop is for this. And it would say it's the local IRB. And that it would be right, because as far as it's concerned, there are 4 interfaces that are a member of that ESI-LAG, and 2 of them are on the local switch. So we need to change this value so that the ESI-LAG those ESI values that are part of ESI-LAG are unique between the 2 data centers that we've now connected. So we modify that, change it to a 4. There it is, and we commit. This dawned on me as I was unpausing. I didn't actually encounter it now and not show you. I did that already weeks ago, so it was still fresh in my mind how much troubleshooting I did before actually running that command and saying, oh, it thinks it's a local IRB. What kind of condition would actually cause that? Oh, and I looked at the route advertisements and I'm like, I'm getting route advertisements that say that the same Ethernet segment identifier is being used by data center B, and that's not good. And of course, it's very well documented, and I just hadn't read that part of the documentation. Let's get into this test host, and let's make sure we can ping, and let's call it a day. There we go. That's from, oh yeah, you're right, that breaks. That's from this host here to this host, and I'll test to this one as well. Oh, let's see there, and there it is. It works. Lovely. Okie dokie. We have our DCI up, and honestly, for a lot of people watching, that might be the lab for you, right? We've got 2 fabrics. We have DCI with over-the-top connectivity between loopbacks and the border leaves. We have test hosts. We have a single tenant, but we have multiple VNs, and we've got a unique VNs that kind of exist in each DC, so we can really test the routing and the stretch L2. This is a fairly complete lab at this point. However, there's still a couple things that I think are fairly interesting that I want to go over in the future videos. One of them is a use case where the peering isn't over the top. There's actually layer 2 adjacency. So I'm going to show you how to do direct DCI between spines. Honestly, you could do it on the leaves, but you can do it on the spines as well. Usually they're beefier devices with higher interface capacity with higher speed links. So if you've got that, you're doing DCI, that's usually a good place to connect them, but you could do it between the leaves as well. We're going to talk a bit about how to peer with a core. I'm going to show you how I can create these links and actually even get connectivity out to the public internet, right? And then finally, the last video I'm going to do is going to walk through some common ops scenarios. This would be more for just sort of playing around and getting more familiar with the day 2 operations. I know even the first video series didn't deal with that, which I felt was a miss. I just sort of ran out of momentum on that. I want to be able to take you through what failure scenarios look like and some of the neat features that set Apstra apart from some of the other platforms out there, and also help give you a more developed understanding of what it means to operate a system that is based on intent as opposed to procedural automation. Thank you so much for watching. This is probably the last video I'm going to do today. I'll finish the other 4 tomorrow and do the post-production over the weekend, which is probably all meaningless to you because these are all going to drop in sequence. I'm just reminding myself of the work that I have to do. Have a great rest of your evening, and I will see you in the next video. Thank you.